So this new book, well, it's not new, it's written in 2010. Sam Kean, The Disappearing Spoon. It's about the periodic table of the elements. And one really great thing about it is it shows people how complex discovery really is and the whole process of doing science and how wrong scientists can be and not admit it for many years. I don't know if I worded that correctly, but basically the progress of science isn't linear. When you look back at the history of how many mistakes were made, how many assumptions that were wrong were made, and how long it took to correct them, it's linear only because we look at it from the future to the past. So we see where everybody was right. We can see that line of progression. But the truth is that it branches out like a giant web. And that's the way it was happening. It's just you only see the one single filament that leads all the way to the past. So keep that in mind. Don't look at science as being something that's progress is linear. It's something that's like branched out and crazy. That being said, I have a new paper here. Well, not necessarily new. I was waiting for the majority of the views to come in for the general theory video that Baz made. Excellent work, Baz. It has 201 views already. But I'll go ahead and keep that up. I'll link that video to the bottom of this video. If somebody wants to watch it, they can easily find it. I'll also link this Victor paper. The stellar metamorphosis, reinterpreting why volatile compounds are mostly missing from the inner planets. I found a little paper here. The abstract goes, quotes are taken from John M. Wallace, Peter V. Hobbs, in Atmospheric Science, 2nd edition, 2006. 2.5.1 Formation and Evolution of the Earth System. Earth System. Here's a quote. The sun and the planets are believed to have formed 4.5 billion years ago from the gravitational collapse of a cold cloud of interstellar gas and dust. And I wrote here, the objects in the solar system are all different ages, with all different isotopically stable, elemental, molecular, and radioactive isotope abundances. That's a mouthful. This is to say, all the major objects in the solar system have different cosmic fingerprints. And this is very important. If you're a detective and you're looking at a crime scene and you see that you have blood all over the place, you look for the DNA. You grab the blood, you get the blood, and you do DNA tests on it to figure out what the DNA is, what it's telling you. And you go back to people and you match up their DNA to see who was actually there. So you have what's called their DNA fingerprint. As well, you have actual fingerprints of when they have techniques where you can take powdered, and you can take tape and remove the print. And there's also different types of frequencies of light you can use to find fingerprints and that kind of stuff. So you have the actual fingerprints of people that were there, and that information can tell you a lot about the crime scene. Now with planets, the crime scene, I would refer to the crime scene as when the sun was born. That's the crime scene. And you have the DNA of the people who took part in that crime scene. So you have the DNA of Mars, you have the DNA of Jupiter, Saturn, Neptune, Uranus, Earth, Mercury. And for the crime scene, the DNA would be the sun's isotopic abundances, meaning where all the abundances of the heavy nitrogen and heavy oxygen and heavy neon and all the abundances that we found in the solar wind in the Genesis mission that NASA had should all match up to the abundances, the isotopic abundances of Mercury, of the Earth, of Mars, of Jupiter, of Saturn. They should all match up because the crime scene says that, or at least from this perspective, that they all formed from the same gas and dust cloud. But what happened is they found that the DNA, the isotopic signatures of the Earth, do not match the solar nebula, the solar wind, the measurements we took from the sun. They're off. So it's just like a detective when they have a suspect and they found blood that didn't belong to the victim at the crime scene. They have this random mystery blood, and they have the suspect's blood over here, and they don't match. As a detective, you could say, well, clearly that's not the suspect's blood that we found that's anonymously in here. It's somebody else. Somebody else was there. Same thing with the Earth and the Sun. When you measure the isotopic abundances of the Sun and of the Earth, if they don't match, then it means the Earth wasn't where the Sun was when the crime scene happened, when the Sun was born. And that's a really big deal, because it means the Earth could not have formed from the Sun's leftover material, meaning the Earth came from somewhere else. It's its own independent object. Same with the Sun. The Sun is its own independent object. And over time, we'll learn that the isotopic abundances of the Sun, of Mercury, of Venus, of Earth, of Mars, Jupiter, Saturn, Neptune, Uranus, and every single object in the solar system most likely are independent, except for maybe like an asteroid. They got smashed up and there's the same isotopes inside of each asteroid. They all match up together. But that being said, they all have their own DNA, so to speak. They have their own cosmic fingerprint. But scientists still, as of 2006, of course it's 2019 now, they still assume, even though all these objects have their own isotopic fingerprints, that they all came from the Sun's leftover material when they do not match the Sun. And that's incredibly anomalous. I'm not going to read this whole paper out, but I'm just going to go over another thing too. A volatile is a compound that boils easy. So a volatile would be like hydrogen gas, or nitrogen, or oxygen, or water. Water is a volatile. It's a really strange volatile because its hydrogen bonds can keep it as a liquid, when all the other volatiles that are actually heavier, like nitrogen gas with its bonds is heavier than water vapor, because it has two nitrogens. The water vapor has one oxygen and two hydrogens. It's really strange to think about it. But you have volatiles that boil easy, and they are gaseous, and they come off the star as the star evolves and loses its mass. It loses its volatiles. So from this perspective, the reason why I had to reinterpret why the volatile compounds are mostly missing from the inner planets was because of this. Not only do the objects have different cosmic fingerprints, the astronomers assume that when the Sun is formed and all the objects that are close to the Sun, Mercury, Venus, Earth, had their volatiles blown off the surface for the most part. When the Sun, because it's really hot and bright, and when it was forming, boom, it blew out all the volatiles to the outer planets, to Jupiter, Saturn, Uranus, Neptune. That's why they have lots of hydrogen and helium, and the other ones, they're missing the volatiles. But that's kind of strange reasoning. That's like saying, well, when you go to a campfire or a bonfire, and you look at the fire and you think, well, the things around the fire that are really close are going to be the things that are burning, that are going to burn easy, ignoring the fact that it's the fire that's burning the fuel in the center of the fire. It's kind of weird, because if the Sun were to be this object to blow off all the volatiles from the inner objects, why is it that the Sun is mainly composed of volatiles? The Sun is mainly composed of hydrogen, helium, oxygen. Those are the most volatile compounds that we basically have in neon. They have the lowest boiling point. So for him to say when the Sun was born, it blew off all the volatiles off the inner objects, when itself is mainly composed of volatiles, it's this weird, like, anti-logic that they have. And what actually happens here is that after the Sun's born, when it expands from the white dwarf stage, it gets really big, it starts blowing off the volatiles itself. That's what happens. And as the volatiles are lost, the heavy material continues to fall and combine into molecular compounds, ionic and covalently bonded material inside the center of the star. And sometimes a lot of it's like pure metal, like, well, not pure metal, but mostly pure, like iron and nickel, and what makes the core. and then it layers the material as that material combines into heavier and heavier molecules. So the volatiles that can combine into heavier molecules, like hydrocarbons, they fall into the center. But the volatiles that never combine, they're blown off. The stuff that's like noble gases, xenon, krypton, neon, helium, those blow off because they're so chemically inert. They just don't want to combine with anything, and they have low boiling points, so that's why they're all gone. But yeah, I don't want to go ahead and read this whole paper. I'll link this to the bottom, but keep that in mind when you look at these interpretations. A lot of the supposed logic that astronomers were using back then, they just like, I don't even know if there's like a word for the kind of stuff, for the kind of thinking that they use. It's like they completely ignore what it is they're referring to. Not only that, but it's doubly weird because, as anybody knows that looks at how astronomers talk about things, they refer to things like oxygen as a metal. This is so strange. I don't know how they managed to. It's like, no wonder they don't understand how planets are formed. No wonder they don't understand how stars evolve. All right, guys. Again, this book. Read this book. Very good. Of course, there's some information I'm going to attack, and it has to do with planet formation, but that's for later. All right, later.